Okay, so hopefully we can catch up and discuss any attempts or anything that you folks would like to share.
I actually sort of got around to making my first submission a couple of weeks ago, but it was just based on sort of, you know, the initial kernel that we'd looked at. But it was using, yeah, like downloading sort of like lower sampled versions of the images, so as I could like run it all on Collab. But yeah, I haven't had very good results yet. So like it was a lot worse than the kernel by itself from the initial thing. So I'm not sure what's gone wrong, but I haven't had a chance to fix it yet. But yeah, so far I haven't got results anywhere near what you've been getting. So yeah, I'm a few weeks behind, I would say.
Interesting. Yeah, I think the of course, in your case, you're talking about actually downloading spectrograms of smaller sizes.
Well, no, it was actually it's like the NumPy arrays. There's in the discussion thing, there's like some guy that he sticks the original wave files, whatever the original sound files, through the thing to generate NumPy arrays from the spectrograms. So like then I reassemble the images to get back to the what the kernel needs.
I mean, right. Yeah, I think that's largely equivalent to, because the images also eventually get stored. But again, if they're NumPy, there may be some other processing you might have to go through to get them to look like images. But
yeah, so it just reduces the size of it sort of down quite a bit. So
right, yeah, because one of the approaches that I've seen talked about, and I've kind of, I've still wanted to give maybe another week or so before, at least week or 2 weeks before looking at kind of the top 50, if you will, because we are at least after several weeks, if I'm still stuck at around 0.9, then the last 0.08 or thereabouts is be interesting. But I still have a few ideas that I want to try to nudge myself. I'm still on the south side of 0.9. I haven't been able to get over that hump, but yeah, so it'd be interesting to give a couple more weeks for people to try a variety of different techniques that are still out there. One of them, interestingly, Steve, if you want to try, since my infrastructure isn't yet set up to do that, I might get around to it this week or next, is kind of this progressive resizing type of idea where some people I've seen are doing the projection, the projections or the predictions on smaller sizes and then incrementally building up the size, and that seems to give them good result as well. So
okay,
since you have it downloaded, that might be easier for you than to do that. I'm still directly operating on Kaggle, so to do that on Kaggle would take both more resources and then everything is sitting in memory, so it'll just spill over. I can't have that many variations of image sizes. Then I'd have to resort to downloading all the things to Collab like you have and working off there, and I've just been too lazy to overcome that barrier. I'm more interested in trying other techniques within Kaggle right now. So
okay.
Anybody else? Alex?
Can you hear me?
Yes.
Yeah, so essentially, last few weeks, right, I mainly work on a Fast AI pipeline. So finally, last week get to a score of 0.76. in the Meet, I didn't try a lot of technique, but instead I found several bugs in Fast AI, or I would say it's not a bug, but essentially some default behavior in the pipeline. I expect it do in one way, but it does not. So I fixed this kind of unexpected behavior. Also in the Meet, I encountered some bugs. So for the default behavior, like, so in the audio, they would do some normalization when you have a pre-trained model, right? Essentially, you try to apply some image net statistic and apply the normalization. But I found that it didn't apply the normalization on validation set. And also, it didn't apply on audio type data. Essentially, I just fixed that. And also, I also found that some metadata is not propagate well to the mail spectrogram data, because how Fast AI work is that you define a data type for different data. So for the audio type data, you have one type. For mail spectrogram, you have another type. So essentially, I need to propagate the sample rate from the audio type data to mail spectrogram type data in order to compute the correct mail spectrogram. But I found that it didn't work in this way. So finally, I fixed that. So at the end, I got, so without, by the time I didn't fix the bug, the score is something like 0.7. So after I fixed the bug, it boosts up to something like 0.76. By that time, I'm still using a basic ResNet 34, a default optimizer from Fast AI, and then do a freeze training plus an unfreeze training. So I think it's good enough. So based on that, I try to apply some quick technique. So essentially, I try out the mix up. So I found that mix up is pretty good in this case. When I apply mix up, the score boosts up by roughly 0.01, roughly 1%. So, and I find it's pretty robust, like, and then after that, right now what I'm trying to do, or maybe I can share the screen. So
yeah, go ahead.
Essentially that there are several directions I can try. So the obvious thing I can try is something like trying out different optimizer. Let me know if you see a screen.
Yep,
so
you can. I can.
Okay, cool. So essentially, I can try out different optimizer, different model, train longer, or resize the image. But I want to put all these things to the last, because essentially just you are trying to optimize the, what do I say? Because I want to try out more on the data side first, essentially expand the data set that I can use or tweak the loss function. So right now what I want to do is I want to do a pseudo labeling. That's what is, when I try to look through the winning solution, a lot of guys talk about pseudo labeling, and they just say that pseudo labeling can boost up your LB score a lot. So I just tried it out. Right now, I didn't fully implement the pseudo labeling yet, but essentially what I do is try to do some POC on pseudo labeling and do some EDA to see whether what I get out from pseudo labeling makes sense. So essentially what pseudo labeling do is you have a train model, right? And with this train model, you want to mine some unlabeled data, because the problem about this data set is that there are some annotation, they are embedded in the CSV, but apart from that, other audio, actually, when you listen to the audio, you discover that there are a lot of unlabeled clip or subclip. So you can hear some bird sound in some unannotated area. So there are a lot of them. So essentially, I want to discover most of them, and then use this label that is discovered by the model again as a new training set. So essentially, it's like a loop. You use the train model to discover some new label data, and you want to include this new label data and train again. So right now, what I do is I already have a train model. I import it into this kernel, and then So what I do is I sample one record. So this record is last for 60 seconds. I think all the record lasts for 60 seconds. And then I run the model prediction throughout the whole sequence. And then right now I select the class that has been activated. So let's say if class 10 has been activated at any time point, I will visualize this plot. I will visualize this curve. So in essence, that should have 24 curve because we have 24 species. But right now I only select one because that's the class that has been detected at least once. So I can see that it seems the model can identify some pattern. So, and then further down, what I do is I try to visualize the region of the audio that has been activated. So you see in the time range from 10 seconds to 18 seconds, it is activated. And from 30 seconds onwards, it's also activated. So I want to visualize the MEL spectrogram on this area. So this area corresponding to 10 to 18. So you can see there's a pattern. So do you see in the mid there is a pattern? You have a how to say, a sharp wave around frequency of 1000 to 4000. And then after this wave, you have a pad at roughly around 4000. So that's the pattern. So that's the pattern that's discovered by the model, and the model thinks it belongs to class 10. And I want to sample. So in this graph, essentially, I want to visualize the region at 30 seconds and onwards. So you can see the same pattern persists. So in this case, I can tell the trained model essentially can capture some distinguishable pattern, which is correspond to class 10. And when I hear that, in the audio, I can't play in this case because I'm presenting in my laptop, but my audio is being used in an iPad, so I think you can't hear it. But you can tell they should correspond to the same species type based on this pattern. And what I essentially do is, so that is what the model has been discovered. And then I want to look at the ground truth. So I want to sample some ground truth from class 10 and try to look at the MEL spectrogram. I would say they are roughly similar in the sense that if you see this, so this is one of the ground truth label correspond to class 10. So you see also there's some wave here around frequency 1000 to 4000. And then followed by this wave, you have a pad at around frequency 4000. This is one ground truth sample. This is another ground truth sample. I can see some similar wave. So based on that, I would say this pseudo labeling seems promising. So what I'm trying to do is I want to convert this signal into a CSV format so that I can include this CSV into my training data set and train again. But there's a issue here because when you see this is the region that the model is showing to be confident. So this is the region that the model prediction give a confidence score of more than 0.5 at the region. So you see this is a signal. So if I extract the region based on this signal, you can see it's not really targeted. I mean, most of the region are not correspond to class 10. What is correspond to class 10 is only a small region. So it's something like 3 seconds to 4 seconds in this graph. So I want to get a more targeted interval in this case. So either I train a model, because right now the way I do it is I train a model on an 8-second interval. But it seems like in this case, if I train on 8-second interval, the subscript or the pseudo label that I identify will be so wide in a sense that they are not really targeted to the region that is correspond to the species. So I'm thinking something like I would like to train a model that lasts for something like 3 to 2 seconds, which is shorter. In this case, I can narrow down the subscript to a more targeted region. Or I can do some post-processing to narrow down this subscript so that to reduce the noise. Yeah, so that's what's going on now. I think probably take me the next week to implement that to train a new model with these pseudo labels. And secondly, what I found is that I remember last time I share about the test set class distribution. And I found that in the test set, class 3 and class 18 is pretty dominant. I think it's shown in this spreadsheet. So class 3 and class 18 is pretty dominant in the test set, which in terms of the distribution is quite different from the training set. So what I essentially do is I just, after I do the model prediction and read and write it as a CSV file, I do some post-processing. The way I do post-processing is that I want to reduce the false negative, essentially some prediction or some ground truth label that the model has missed. So in order to do that, I want to minimize the cost that is induced by this false negative. So in order to do this, what I do is for all the negative prediction, I reshuffle that, or I just impute that, replace them value. I essentially replace those prediction score by the class weight. So what you would expect is that after I replace by the class weight, the class 3 and class 18 or other dominant class will jump to the top. In this case, I can minimize the false negative because most likely the false negative will be class 3, class 18, or some other dominant class. So if I enforce them to the top, I can minimize the metric because the metric concerned about the rank. So after I do this simple post-processing, my score jumped up by 6%. So you see the row 23 is the score I get without the post-processing. So row 24, I add a post-processing, other things are the same. So you can see the performance gain is quite significant. So it shows that the post-processing is quite effective and it's a quite good way to utilize the test set distribution. But also it shows that my model has a lot of false negative. Otherwise, it won't have such a large performance gain. I would say it's the simplest way I can think of to embed this test set distribution. There's other way, but I'm still thinking about that because right now the way I do it is I want to minimize the false negative based on the prior knowledge I know about this test set. But I think I can also use this information to reduce the false positive as well. But for that, I need to think about that. Yeah. So that's what I found right now. Originally, I target to have an LB score of around 0.9. By this month, I think it's not quite achievable. Probably I need to take the next week and try out the pseudo labeling to see whether I can boost up to 0.9. I think pseudo labeling can probably get me to 0.9, given that it can help me discover a lot of unlabeled data. Right now, I just target to mine the data from training set. I mean the true positive, the recordings from true positive. I think I can also mine the unlabeled data from test set and also from the false positive recording. But I'll start with the true positive first and see how it goes. Yeah, I think that's what I get. So do you guys have
if you
any...
And if if you had a chance to listen to, I think it was last week, Arto was there, so he can comment if I misremember. But last week or the week before, I went through the summary of what the original paper, and I posted that paper as well. So two comments relevant to what you're doing. One is, this missed labels on the training set is something that is definitely there in the data, and that's something we discussed. I think it was last week, based on the methodology that meaning the team which published this data for Kaggle competition, based on the methodology they adopted. So if you read that paper, what they do is they run a template to compare.
I read that.
They run, yeah. So based on that, then essentially what you're saying is actually confirmed by that paper that, because of the misses by the template, there are sounds or bird or frog sounds in the training data that are not annotated, and that can be used. Now, fair warning though they give is, although there is missed data, it is sometimes tricky because ambient noise is also there in different recordings, and sometimes the intermixture of ambient noise and a legitimate sound by one of the species, they combine in a way to result in mispredictions. That is, instead of it, meaning instead of thinking that it's species 10, for example, to pick a random number, the intermixture of background noise plus the actual sound of 10 results in a kind of some models predicting, let's say, species 15 more because of the interaction of the two. So there are a couple of problems. One, that there is missing data or missing annotation, as you said, and there are sounds in the training data which are not labeled. But more importantly, the other second level complex problem is the interactions cause the model to confuse labels even when it is predicting. And so that's where, to a certain extent, they say, that the false positives help as well, because there they clearly tell you, oh, this is very clearly not species 10, even though the sound appears close to species 10. So, and like you mentioned, I think multiple people, and I haven't wanted to look at the details, as typically, we wait at least a couple, 3 more weeks, maybe, for people to try a variety of things, and then we look at, the kind of the top results, but to see what things we are missing if we can't progress beyond 0.9 after trying for several weeks. But like you said, many people have adopted approaches that you're on the path of, which is to say, hey, can we use our model to predict the labels and then use that in turn to train another model, which would give us the final predictions. And there is some, it's somewhat like, although it's not, I think there are some differences. One is this pseudo labeling approach. The other kind of approach that I've seen discussed is the teacher-student kind of approach. And there, especially with your, labeling, Alex, which you talked about, of the time, how you may need to shorten the time period and stuff. One of the things that is also discussed is, I think last week we discussed this as well, is using weak and strong labels, and then and I bring it up in the context of the teacher-student network. Again, I haven't tried this approach, but some of the people have discussions. We'll see whether that approach is necessary to get to the top results, but some people have talked about using kind of weak labels to predict first and then using strong, or vice versa, meaning using strong labels first and then predicting all of the species that are there in a sound clip, for example.
Yeah, right now, it seems to me pseudo labeling is the simplest way to start this direction. Another thing is like, by the time you talk about the mislabel, do you mean that the true positive is actually not a true positive?
Sorry, could you repeat that?
By the time you set the label is mislabeled, so do you mean that the true positive end up is not true positive by the time you inspect that?
Actually, is that true though? Because the true positive is definitely true. It's just that there are other missed, and I don't know whether it is in a recording, whether the same positive is missed or it is missing other positives. I haven't looked at the per recording stuff, right? Because I don't know that any true positives which are given as true positives in the training set are not true positives. It is more the fact that the true positives don't capture all of the true positives that are there. There may be missing true positives in your training set.
Yeah, so in this case, I think it means the same thing that I say is there are a lot of unlabeled data, right, in the recording.
Correct.
Yeah, so for that,
is accurate.
So I also read the paper. So I think I originally guessed it is using some template search. So I think this paper confirmed that, because by the time but one more thing is I try to integrate the weight and bias into my pipeline. So I just use the helper function from the helper callback from FastAI to do that. I think it's pretty straightforward to integrate that. So I can show you some sample dashboard. Wait. Yeah, I think it's this project. So essentially, I have different runs, and over different runs, I can visualize the metric, validation loss, training loss, and all the other hyperparameter over time. So you can see there's a weight decay, learning rate, moment. I think it's really handy right now. What is nice is that it also helped me to save down the configuration. But I would say in some cases, the configuration save is too granular. It's not to the thing that I'm really concerned. And also, I think it's also the same for the graph. Like the hyperparameter, the momentum or weight decay over time, probably I don't need to concern about that. So probably if I have some time, I will customize this weight and bias callback. And also, okay, that's one thing I do on weight and bias. Second thing is I try to do some EDA with weight and bias, because if you recall last time, when IS give a presentation, weight and bias have a new feature, which is called a table. So for this, it's easier for you to do some EDA because you can plot out the image, audio, or spectrogram on a table, and you can compare them one by one, or you can group by the species ID and sample check that. So I also do that. This is because by the time I try to generate this table, I encounter some issue here. This is not the one. Wait me a second. Yeah, so this one does not look good. Okay, I think it's this one. So essentially what I do is, because one in the CSV, one row is correspond to one subclip of a species, right? So essentially I do the same. So I just visualize the localize my spectrogram, and also try to localize the frequency region, the frequency range and time range of that species. I have the recording ID, I have the audio I can hear, I have the species ID. So essentially I just visualize that like this. What I found is that if I group this by species ID, what I get is that the frequency range is the same and the time interval is the same. So it kind of verify the hypothesis that this kind of label is actually generated by some fixed bounding box, which I will refer to the template. But right now there's some issue because right now this table only has 30 samples. Maybe I can do some sample group by. If I group by. So what I encounter right now is, I think there's a bug in weight and bias. When I try to upload all the samples to weight and bias, because what it works is that I upload the samples, the whole table as an artifact to weight and bias, and then it will work. But I think I encountered some out of memory error by the time I try to upload that. And I think it's a bug. IRC is trying to follow up this issue. So I think it will be fixed soon. But meanwhile, I think I can try to group this number and verify what I said. Yeah, so right now I try to group by the species. So if you notice species, okay, species, what's this species? Okay, species 0. So if you look at species 0, there are 3 species 0. You will notice that, okay, the bounding box looks exactly the same in terms of the size. And if I look at species 10, there's 2 samples from species 10. You also notice the bounding box is exactly the same. So it's kind of verify the hypothesis. They're using some kind of template to detect that. One more thing is that I think in the later on stage, I need to inform the model about the frequency range of the species. That could more effectively narrow down, more effectively remove the noise and more targeted to the useful characteristics of this of the region of the species, because every species has its corresponding frequency range. So it's good to embed this information to the model. In this way, you can reduce the noise.
Right, that's true. But also, if you were to look at 23, if you can zoom in on that, how wide in time is that?
How wide in time?
I wonder.
You mean bounding box?
Like, yeah, because if that seems to be about, I don't know, 1 to 9, 8 seconds or something, right?
Yeah.
Yeah. So 8 seconds or something. So if we look across species, the other reason I'm interested is if we chop, like I'm doing, at least my approach where I chop to focus in, and the question is, is 5 seconds too little to get a good representative sample for a species? And do I need to make it 10 seconds, for example, to capture, or within the 5 seconds, is there a repeat of the sounds to where, when I chunk it to 5? So the examples you have captured are very useful to kind of look at that type of data, right? Because here it seems like
you can see
slice is about 14 seconds.
Which species?
I think the 114 or something that you were on a minute ago.
14 only. Yeah, you see 14 only lasts for 0.5 seconds. So it's really short.
Okay, it's why I thought it was 15 versus 1.5. Okay, never mind.
It's pretty short.
So I think most of them would probably fit in 5 seconds. I would venture to guess.
So sorry, Alex, I missed this bounding box. It's drawn by tmean to tmax and fmean to fmax, right? Or
yeah, based on tmean, tmax, fmean, fmax.
Okay.
Yeah, so I would say if I want to embed, because I see some people suggest a solution is that that's the easiest way. Essentially, you just crop this region and then resize it to a fixed size and feed it to a model. But if you do this, you need more work in the inference, because in the inference, you don't know which frequency region you should crop. So you need to do a grid search over all the frequency range.
I guess you can try to input it as kind of auxiliary information, right? So when you do the prediction, you can kind of like use a parallel network which only works with tmean and like fmean and fmax, and maybe that would inform the convolutional network to focus on this frequency region. But maybe later it's better to like when the network learns to attend properly, maybe it's better to remove this information and for example when you do relabeling, I don't know, or maybe after you do the relabeling, I guess, because basically like at the inference time you kind of don't know what frequencies to attend, so it's much better when you can just push all the like all the image through a network, right, and get the prediction. But you want to yeah, and I think that's a nice use case to like use that GradCam if it works properly with this, and to try like to train the model to the level when it can like output.
You mean
yeah. It's a tool to visualize basically the activation region.
Oh, I see.
So yeah, I tried it with my like in one of the yeah. Maybe I will just make this notebooks public because I don't think I made it public. It was just a little messy notebook, but I applied it to that my network, which I used to input the full length audios, and the output was kind of showing that it does not activate properly. Like
I see.
Yeah, and
But what's the purpose of this model?
excuse me?
What's the purpose of this model? Like because it's outputting the. Oh, you're trying to debug whether the model is learning something useful,
it's
right?
kind of interpretability tool. Yeah,
I see what you mean.
So and what we discussed like in the last session, so but I still haven't like got to really make it work as well. So I was thinking about like you can train first this model in a localized fashion, right, and get it to attend to the interest of region. Right? It's easier to learn to like really focus on the relevant area if you like train it on this cropped images.
Yeah, you mean crop in the region of interest, right?
Well, I was thinking of cropping the time only, but maybe cropping frequency. Like looking at your notebook, it seems like maybe cropping frequency might be useful. But on the other hand, you kind of can maybe get much more data from this by doing just multiple time crops.
Multiple time crops.
Yeah, so
Also,
you can like crop at the very beginning and at the very end, and maybe to make the signal at the center. So you can like really make sure that your model attends to this particular scene by like feeding it kind of different spectrograms with the same signal, but you know, if you crop it like basically sometime back, and hopefully it will learn to identify this particular useful signal, right? So that's kind of some. Yeah, in my pipeline, I tried to make this time cropping randomized, but again, I haven't yet like really.
Yeah,
so how do you randomize it, Arto? Are you taking the when you say randomize, how do you randomize?
So I take the center of the relevant signal, right? And then I can shift it up to like, you know, to the bound when the signal, like to this t-mean, right? So the frame I'm looking at can be like, can start either at t-mean and go to t-mean plus 10, or it can start at t-max minus 10 and go to t-max, you know, and anything in between. And,
so you still stay within t-min, t-max. It's just that your slice start and end times can be different, but limited still by t-min and t-max. Is that what you're saying?
Yeah. So maybe limited by t-min and t-max. I don't quite remember how I decided to do it, because there are some kind of signal which have a long time span, and maybe then you can kind of like crop a part of it out. Yeah, but I'm also using FastAI, and I just did it in the data block. So the samples kind of generated dynamically, right? And you can adjust it. I haven't really like tuned it to work nicely, because yeah, I was just trying it with a small network, and now I switched to ResNet 34, but it's still kind of small. I think the one you used to get good results was like improved ResNet 50, right?
No, I actually use ResNet 34 only.
Yeah, I think Srinivas was using ResNest, which is like in size equivalent to ResNet 50.
Yep, ResNest 50, and then because that model thing, and Alex was pointing out too that the guy put it in Dropbox. I still tried that, and that didn't work, so I switched to DenseNet 161, but which gave me equivalent results. But yes, ResNest 50.
Another question I got to you, Alex, is first, I think like, have you tried ensembling yet?
So I haven't tried yet, because I only have one model.
Yeah, so I'm also like, I want to train the whole ensemble for pseudo labeling. I guess it should work kind of better, but yeah, haven't finished it yet. And another question, like I saw you had like a lot of epochs in the fine tuning stage.
Yep.
Did you find it kind of useful? Because
yes, it's useful, right? Because you see the curve. So this curve includes the freezing training plus the unfreezing training. So I think in this case, I said the first 10 epoch is the freeze training. It means that you only train the head. And after that, I do the training across the whole body. So you can see actually it really helped on the metric.
Yeah, so my question is, have you tried less freeze training, just to let you know to switch to kind of trained a freeze model just a bit, and then go with unfreeze training.
Oh, so do you mean that is I alternatively train the head, and after that I train the head plus the rest of the body, and then after that I train the head again?
No. I mean like just to decrease the first stage to say like 5 or 4 or maybe even 2 epochs.
I haven't tried it.
So yeah, and I was using like a short this fine tuning like first stage. So I was just curious if you tried it, and I was curious how it compares, because like what I like intuitively guess, I would say, so that's not kind of information which might be like reliable, but that's just my guess. So the network, initial network, is not suited for spectrograms, right? It's suited for natural images trained on ImageNet. And by training it for a while like frozen, we kind of try to get this head like to squeeze the best performance from the head, right? And then we start with this head, like really, we can say like well-trained head, but it might happen that this would be kind of suboptimal for the final performance. So that, and I don't quite like 100% sure if that's like a universal rule, or just something that people didn't yet figure out. But when fine-tuning transformers, you just what you usually do, you just train the whole model from the start. You don't do this freezing unfreezing. And why you don't do that? Because it actually usually results in either similar or worse result. And yeah, so the comment from Sylvain, one of the developers of FastAI, who works in Hugging Face now, was that like he assumes that the model kind of ends up in this suboptimal region and cannot get away from it, you know, to get to the better optimum in the when you unfreeze it, you know. And I wonder. I'm sure that this freezing unfreezing works with vision models, with convolutional nets, because you know it's a kind of well-established best practice to do it. But so here I wonder if what would be the best amount of freezed training because of this domain shift.
Yeah, for that.
What head? Sorry, go ahead.
For this, I can't draw a conclusion yet. So probably I need to train without any freezing to verify that. But for your claim, is it mainly comes from the RNN network or on the NLP experience?
Yeah. So my intuition comes mostly from NLP experience, and that's not a complete. Kind of not really directly relevant, because that's particular to transformer architectures. For example, if using RNN-based architectures, you still get better results with freezing unfreezing, and also it is possible that you can maybe get somehow better results with freezing unfreezing, but just I don't know, people didn't figure out like a good schedule for that, or maybe or something, I don't know.
Yeah, because based on this graph, I think the model right now is good enough in terms of baseline. So I didn't further fine tune the training scheme or the model yet, because when I try to compare this with the topic kernel baseline, so I can see the score is actually roughly similar. If I look at the public kernel, the score they get is something like 0.75 or 0.7. So I think it's kind of aligned. But of course, I think at the end, I will try different training scheme, including to change the model that I use, because as you said, the ResNext or the bigger ResNet seems to be more useful. But do you find that it's a big margin in terms of performance gain? If I change the model?
No, I don't think it will be really a big margin. It might be just a bit, but also like an open question how it plays with ensembling. Yeah, and another thing I was thinking about for relabeling or pseudo labeling or however we call it. So just getting this idea from the one thing there is one thing I'm working with which involves uncertainty score, and another thing here we were looking at this paper at the previous learning group, the PyTorch deep learning, and they used uncertainty regularization for training. So basically what you do, you take the model and you get the predictions with dropout. You keep the dropout on when doing predictions. It's called Monte Carlo dropout, if you're familiar.
I see. So in the inference, right? In the inference, you keep the dropout on.
Yeah, and in this way, you get the uncertainty score. And I guess we could try to use this uncertainty score when when outputting when relabeling. So we could use this false positives and uncertainty score to make relabeling kind of better. But yeah, those are ideas for the time when we get it working at all, right?
Quick question, Alex. What kind of a head are you using right now?
The head, maybe I'll give you some time. Oh, my session is restart. I think I use the head that is offered by FastAI. Essentially, I think I have a graph. Nice thing about weight and bias.
Meaning, is it just is it multiple layered, or is it just a single layer going from the ResNet output to the?
It's multiple.
Okay.
So I use adaptive concatenate pool and then flatten it, and then go through another linear layer, and then the final linear layer. So 2 linear layer.
Yeah, and I think Jeremy and guys in FastAI investigated it empirically and found this works generally better than regular one layer, one pooling head.
Yeah, I think something different about FastAI setup is that it has such an adaptive concatenate layer. So you have these two types of pooling. I think it's average pooling and maximum pooling, and you concatenate them together before you flatten it.
Yeah,
they do that, which is, like you said, unique to FastAI. Most others do one, they do both, and they just concatenate them together.
Yeah, it's interesting. We can basically easily compare. We can add this FastAI style head to the network Srini was using, and just compare the result.
Yeah, no, I did that. If you recall, it was one of my, I don't know whether it was exactly the FastAI stuff. I'll go back and try it if it's not exactly that, but I remember that I used instead of a simple single layer linear going from output of a ResNet 50 or a DenseNet 161. I think I did it more for ResNet 50, if I recall. in one of my ablation type of studies, and stuck in a multi-layered network head, and my scores were flat to down.
Yeah,
So
but I guess you didn't have batch norms, and you see FastAI uses a heavy dropout here, like 0.25
that's something
0.5 in the last layer.
Yeah, that's something that was pointed out. So I need to try it with probably, I'll just kind of look at this head that FastAI uses in particular and kind of try and duplicate or exactly duplicate that to see what happens. I haven't done that with the ResNest or Lens. Actually, I would have preferred to have done it with ResNest 50. And I might still go back. As I mentioned in one of my last, I think 2 weeks back, it's kind of interesting that the ResNest that I took out from the original paper guy where he had stored it, turns out that ResNest is different from the TIM ResNest. So which itself is kind of annoying, but I think maybe the pre-training and other things was done differently to where a slight difference. The TIM ResNest model doesn't give me, of course, I'm talking, fractions of points, but fractions of points are still percentage points, but fractions of percentage point differences are still annoying. So that's what I found. But to your point, yeah, I'll go back and try with this particular head stuck on I would have liked to do it with ResNest, but I'll try it with DenseNest and with the TIM ResNest as well.
So are you saying TIM's model are worse compared to the original one?
Yeah, slightly. The TIM, I tried, there are multiple ResNest variants. I think, I didn't dive. That's one of the things towards the end that I'd like to do is look at the ResNest paper and kind of understand, how it's different or changed from ResNet. But TIM has different variants of ResNest 50D, and I tried both variants, and neither of them, one is I think a little more complicated than the other, and of course, since they're pre-trained networks, it's not a big deal for us, but neither of them gave me the results that I saw from the original guy who wrote the paper and had pre-trained models stored. But then he still hasn't fixed. He said, try this on his website, and I tried, and that still leads to some other problem somewhere in interaction with PyTorch. So I just gave up. I didn't want to spend time debugging that.
Okay, I wonder maybe there are like uploaded version of ResNest on Kaggle. People often upload the pre-trained models to use them like with no internet connection.
Yeah, I haven't checked that. You may be right, so I haven't looked at that to see whether there is a ResNest 50 pre-trained, preloaded that you can use. But, most people in this competition, because it's just the submission files and stuff, were kind of downloading it. And then Alex pointed to, yeah, there is a problem, and that owner put it somewhere where there are limits on how many accesses, and there are a lot of people using his model, so it stopped working. And he thinks that he has fixed it, but again, there are problems. So,
okay. So another question I got. Do you remember what was the performance gain when you moved from a single model to ensemble?
Try ensemble.
In fact,
or you do how about sorry.
Go ahead.
For me, I didn't try. So do you try that? Try ensemble at code?
Yeah, I did. And in fact, I think in one of my I think 2 weeks back, I went through, which actually leads me, let me show you guys something that I did last week that I still am trying to understand. And maybe if you folks have already know this, then you can, so if you
Okay. Shall
let
I
me
stop
share,
sharing
Alex?
then?
Yes, please. Okay, let me see. So let me know when you can see my screen.
Yeah.
Okay. So I think few comments and then a question. So the comments with respect to, you know, I had shown you folks, and I'll show the notebook because I just modified the notebook to do something new. So this ensembling my runs was what I had done, where I, you know, just basically could combine my submission files in a variety of different ways. Take the min, take the max, take the average, take the combined, combine them in some proportion type of stuff. So I set that up based on another notebook that was existing, and none of them gave me better results than my, so far, if you folks recall, my best results were these, okay, which is, you know, private score of 893, public score of 887. And that is with the basic, you know, where I chunk it at 5 seconds. I use the FFT of 4K. I use the setting to generate the MEL spectrogram to be amplitude rather than power. I mean, the value of power is set to 1 in the Librosa. And then I use the DenseNet 161 network. And then obviously I do the, you know, pick the max values because I'm chunking. So obviously on the test side, I have to combine the chunks, which is 5 seconds. So I take the max of 12 chunks, and then I do 5-fold validation. So I combine again the results of all of the 5 folds to get to that.
So you combine the 5. Sorry. So essentially, the way you do ensemble is you ensemble the 5 models from different cross validation sets.
Yes, I average the. So I get 5 models because I have a 5-fold validation. So each of the models then will predict, right? I use the average of those 5 predictions to come up with this. When I get to the test set.
Sorry, can I understand more about your audio configuration? The HIFFT, what does it mean?
It means I just used, so let me see if I can just show you that particular notebook so it will be easier. Can you see the notebook?
Yeah.
Okay, so this basically says, you see the setup here where my base setup was FFT sampling rate, not sampling rate, sorry, the FFT window thing was 2K. Instead, I go to 4K.
I see.
But I'm retaining the hop at that.
Also,
and then obviously I'm taking 5 seconds.
As well. Okay.
Sorry, Alex?
Do you think changing from 10 seconds or 8 seconds to 5 seconds give a significant boost?
Yes. In fact, let me see. Where was, which one is these?
I think I missed out your session last time, so I will know more about what kind of configuration gave a significant boost on the audio clip data.
Yeah, so that's where, you know, I went through this, I think, last week because Gautam had asked. So if you listen to last week's recording, I think I go through kind of like, you know, where I started and where I ended up. And if you see, all of my original runs were with 10 seconds. And where you see the 5S win appear, and then I shortened it to 5 seconds. But wherever you see the number 5 show up, that's when you see me switch from the base kind of thing, which is 10 to 10-second chops to 5-second chops. And you can see there is improvement.
Okay, 1 to 2%, quite big.
Right.
Okay.
Yeah,
quite big.
Exactly. So, it does seem to matter.
Mm.
And then you can also see, again, I did 5-second, but with the FFT of 2K. And then a high FFT means, again, these are just code words for myself, so I can quickly figure out what I'm doing differently. Is this result I get is with the
so
FFT of 4K
double the
versus
duration of FFT.
Exactly.
Mm. So what is AMPL?
Right. This is just the amplitude. So that's the power setting that I talked about. So if you look at this code, when here, so you look at how you give a value. Again, I'm using Librosa to convert to MEL spectrogram. So when you do that, you can provide a value for power. And the value of 1.0 means it's an amplitude. A value of, you can actually give any value between 1 and 2. And the power of 2 means it's actually power. I don't know why they use this term. I wish they use some other variable name here. But bottom line, a value of 1 given to power means it's a plot of the amplitude in a MEL spectrogram. And a power of 2 means it's a plot of actually power. And you can actually give anything between 1 and 2 here as a float. So I haven't tried.
I guess something like you try to do some exponential power. But if you set it 2, it's something like a square of your amplitude.
Yeah, exactly. It is a square, right? It's a power plot in a MEL spectrogram. So the color that you have on a frequency time thing is a power plot because it's a square of the amplitude. Whereas this is just a plot of the amplitude. The color plot in a spectrogram that you see, the color is correlated to the amplitude. So that's why I started calling this amplitude, because I switched this 1 rather than the original 2.
And
so
that, you are still using the decibel. Okay.
That, as you saw, also caused between this and that, everything else is the same. So that also causes a jump.
Okay.
And then from here to here is the only change is the FFT. So you can see I kind of varied 1 parameter at a time to see whether it improves, and then I got to this best result with this set of configurations.
DenseNet 161.
And that's the one that I posted. That notebook is what I posted, I think, like last week or week before.
Hey, but
right, and then I was playing with.
Sorry, is it slow to train the DenseNet 161? How long does it take for one epoch?
Don't recall, but the whole thing didn't take, because again, I'm using pre-trained weights.
So you don't train the head? Okay. So it's not a big deal.
Yeah. So the thing I wanted to, and to answer or kind of partly answer, and we'll get into the details of Atto's question. I did, now keep in mind that I'm already ensembling, but in a way, it's just averaging the 5 folds, right? So I'm not referring to that as ensembling, even though it is in a way, because I'm ensembling 5-fold or 5 different models and averaging them to get my results, right? So that itself is, base averaging. But then this ensembling, I was actually taking the results of my submission files from all of these different experiments I had done, and then trying to combine them. And I'll show that notebook in a minute. But basically, it's set up so you can combine the 2 files by either doing the min, the max, the average, or a weighted average of 2 values. But none of them gave me, keep in mind that this is my best results, right? 893, 887. So you can see while I'm getting close, but none of them, again, 893, but 346, 341, 887, 886. So this is about as close, but again, keep in mind that this is better than that guy. So even though my ensembling got close, but nothing, and for example, here I tried, if I recall, I'm talking from memory, but here I tried to ensemble a 5-second chop and a 10-second chop, I think. But the question I wanted to get to, so before I get to the relevant part, just to give a interesting side note, I did try Meetup, and just to illustrate that, it also seems to be one of the things I've learned, at least in Kaggle, is, or by doing it, is there's no universal statement that you can apply saying Meetup will help, or such and such will help. Everything is situation dependent and empirical. So the reason I say that, I mean, it was shown repeatedly by Steve in multitude of the previous competitions, and I encounter it in this case also. The reason I say that is, like we saw how Meetup helped Alex's setup. I think it helped Arto also there. But I implemented Meetup thinking that it would give me significant improvement on my base setup that I had, which I had gotten the scores I showed you earlier of 0.89 and 0.887, but actually I got lower results, as you see here. Not as good as the base, which is, I guess it's again depends on a lot of the details of what you have in your network. And the other thing which I didn't try and which I need to go back and try is my Meetup value was fixed. I didn't sweep or try multiple values, so I just kept alpha to be 1. That might be an issue. I think somewhere I saw that, if you cost more of a Meetup, then it might help. That's something I will try, but given the drop, it might just get me back to where I was.
Yeah, about the Meetup, I use the FastAI callback, and it has a hyperparameter. I think it's using, what's the hyperparameter it's used? So you have an alpha, right? The alpha will control the string.
Yeah, no, in this case, since I'm not using FastAI in my setup, I actually coded in the Meetup based on a reference code, and I actually implemented Meetup in my flow.
Just for your reference, the alpha that I'm using is 0.5.
0.5. Okay. Yeah, I'll try with that.
Yeah, you can try.
Yeah. A couple of questions of how you use Meetup. So first one, did you remove other augmentations?
No, I still use the basic basic image augmentations that I already have in my pipeline.
Okay, so one idea why Meetup might not help is that might be too much of augmentations for this setting, because Meetup itself is kind of strong data augmentation, and if you have it already augmented, I don't know if that's one thing. Also, for how long do you train with Meetup as compared to previous runs?
I didn't change or increase the training.
Oh, so another point here is that I'm not really kind of experienced with this, but what I've saw that you got to increase probably at least 5 times, do like at least 5 times more training with Meetup, because it's kind of strongly prevents overfitting, but on the other hand, it requires like fairly more time
training
to converge. So
okay, no, those are good inputs. So I'll try, you know,
interesting to compare, like change one thing
right.
at a time.
Yep.
And see how it works.
Yeah, no, that's a good idea. So, you know, removing other is fairly easy enough for me to do. Remove the others and just try mix up, increase mix up training, and to Alex's point, try with a 0.5 alpha value and see what I get. That would be good experiments to run this week. Thanks. That'd be excellent. Okay.
Another thought about it,
go ahead.
Just one more thing. So I'm not like 100% sure if you have like a fixed backbone here. Maybe it also causes some problem. Like maybe it has like worse compatibility with mix-up, but that's just like a wild guess, you know.
Yeah, I mean, I have it. It's easy enough for me. I've already changed the backbone, so I can change it to rest nest and see whether that has a better outcome than densenet. So I can do that experiment.
What I'm referring to is, as you said, you are only fitting the head, right?
Yeah.
And so I wonder, like because mix-up is kind of this kind of heavy augmentation, and it might be that kind of the convolutional filters you need to make benefit from mix-up are different from those you need without mix-up. And if you keep your
so you're saying you may need to,
fixed,
need to also train the also allow for training of the backbone with mix-up in order to get better results. But there the concern is, you know, the trade-off between that and how much my weights are going to get screwed up by that. Yeah, so that's interesting. Okay.
Yeah, that's kind of like really open. All are open questions about it, and yeah, it's curious.
Okay. So let me show you guys. So then, one of the things I saw somewhere, and therefore I thought, okay, this is an interesting thing to try, and it yielded me slight improvement to where these are now my best scores. And there is a question here that I'll point to, which I don't get. And maybe any of you, if you have seen it and can quickly explain it to me, I have to dig. I did it late last night, so I haven't yet dug into the code to figure out what it is doing differently. But I'll point to what the stuff is. So in this notebook, so this notebook originally was what, or a variant of it was what I was using for ensembling my runs. So there, let's just say I just kind of stick, sorry for rapid scrolling, but I just wanted to point out what I was doing is just sticking a bunch of parts, which are all my results. I've gotten more results since then, but about 13 of them in a data frame, and then I can just pick the parts, and then it's set up to where I can generate, depending on what combination I want. I can just use either the max, the min of two things, just the average of two things, or I can give it a coefficient and get a weighted average of those two things. Right. So this is how I generated the ensembles and submitted them to see the scores based on, you know, like for example, I told you I was trying to ensemble, say, a 5-second score and a 10-second rest nest score. And this is the one that got me, I think, if I remember, kind of close to my best result of just with densenet, but still not better than, just close to. So that's what I was doing. Now, here's an interesting variant on it that I saw that I just used this setup. And that is something called rank averaging. So have any of you tried it and can explain what rank averaging is as opposed to just the averaging that I just showed you?
Do you mean the block 37 is the rank averaging logic?
Yeah.
Let me see.
Actually, that and 38. Okay, but again, I will dig into it and kind of present because I kind of, anyway, so this is what it's doing is it's ranking the, keep in mind that this competition, it's always just the ranking that matters, right? It's the label ranking, meaning as long as within a recording ID, let's say it's 3 species, right? Like 5, 10, and 15. As long as your rank of 5, let's say in ground truth, the rank of 5, 10, and 15 is in the order of 5, 10, and 15, then as long as in your predictions, the rank ordering, forget about the scores, the actual value of the scores is irrelevant. As long as your rank ordering is in the order of 5, 10, and 15, you're good. But if the rank order switches so that you get 10, 5, 15, then that's a problem or you'll get penalized. So only the rank matters. So even if your score for, let's say, class 10 were to increase by a certain amount, but it doesn't change the rank of species 10 in a prediction, it doesn't matter. Because only when the rank changes, so that means that only when 10 scores get better than or worse than what's next to it, will the score change. Okay, that's the nature of label weighted, label ranking, average precision. So here, he's doing rank averaging, and I'm still trying to figure out the details of how that's different. In the process, I did find a very interesting post that I think would be useful for us going forward. There's this post. Sorry, I think that's not the one. Let me see whether I can. Sorry, I'll post it. Sorry, I think I missed the website, but I'll post it. There's one thing called Kaggle ensembling guide. Maybe I'll just go there. That's the site I'm looking for. Oops. Maybe not. Okay. I'll post. I know where to find it and I'll post that. But it basically gives all of the different ensembling techniques that people have used, including stacking, blending, and it does talk about rank averaging. But again, just quickly scanning it last night, I wasn't able to figure out where I could explain to you folks how rank averaging, and again, what I was looking at is how rank averaging is different from just combining like I was doing before. So essentially I compared, so, this rank average implementation, which combines, and again, I have set the weights to be 0.7 and 0.3. And if you go back and look at this notebook, and I'll post a link to the notebook, previously I was also combining the two results using weights, but just multiplying one by 0.7 and the other by 0.3 and combining the two. But the rank averaging obviously is doing this, sorting, and by rank, this is where I think the magic happens, because it's arg sorting the values along the of the columns, which means that it's sorting and creating the rank listing. But then I haven't figured out why or how this is different. So I want to play with a smaller things, not all this 22, 24, blah, 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 but figure it out in a small example to where I could explain it to myself why the rank averaging and how that's different from the basic averaging that you would do. But what is interesting is that the scores are different, or my submission is different. I check that by looking at the two. This is my previous one. Actually, yeah, this is my previous one where I'm doing the basic 0.7, 0.3 combination, and this is my new one. And you can see from the descriptions of describe that the two data frames are different, which means obviously the rank averaging is doing something different. So I confirm that. Now, how it's different, I can't explain. And that's why I was asking if anybody has seen or understand how the rank averaging is done and why it's different. But anyway, something interesting, which gives me though a better results by rank averaging the two rather than just basically averaging the two. And if you see, this is now my best score, 0.895 versus 89577. Let's see whether I have best before that was this guy.
Okay, right. The difference is kind of small, right?
Yeah. It's tiny, but I just thought it's still interesting that way of averaging gives me a better result.
So it does.
So I wanted to understand.
It uses argsort there. So argsort is returns just an indices of the ordered indices with respect to the value.
Right, which is why I was saying that this is basically doing rank ordering, right, rather than values, right? Because by getting the index of the value, it's actually saying, give me the index of the highest value and put that first, right?
Yeah, so we kind of exaggerate the difference between or not exaggerate, but we kind of fix the difference here between ranks. So it just now our scores are ranks, right? Like from 0 to 23, and arranged with so we kind of change the how would I say it? So we like manually set the scores we want to have, and
right. But what I still can't figure out, Otto, is if by changing the ranks, right? When you're combining the two, let's say I have two CSV files, right? Two submission CSV files, and in both I'm using the weights of 0.7 and 0.3 in both cases, okay? In one case, when I'm doing, let's say, the non-rank average, I'm just multiplying the values of something by 0.7 and adding to 0.3 and then dividing by 2, right? And in this case, I guess the only thing I don't do is I don't divide by 2, but that's just a proportion, right? That shouldn't change my eventual, I mean, if it doesn't depend on the actual values, then whether or not I do scores times weights by 2 should not matter because it's just a constant. So then why is this result different than what I was doing previously of just multiplying 0.7 times one value and 0.3 times other value and adding? So that's what I can't
I'm pretty sure you shouldn't expect those to be the same, because basically you can view this operation like arg sort and then like assigning the scores like to concrete values as a non-linear operation, right? And you don't like, there is no reason to expect to get the same ordering for two, like one is linear combination and then another is some non-linear mapping, right? Like just from pure mathematical perspective.
But why do you say that? Sorry, yeah, this is the part where I'm maybe just slow in grasping that, because let me tell you where my confusion is. My confusion is you have a row, which is a set of value corresponding to S0 to S23 with some values. Now, and you have a similar row in another submission file that also has 0 to 23. And in the traditional simplistic averaging that I have in, right, forget about rank averaging. In the simplistic averaging, all I do is take 0.7 times the S0 value of from my first data frame and 0.3 times the S0 value from my second data frame, and add the two and then divide by 2. And that's my resultant S0 value. And then I do it for S0 through S23 for each of the rows in both of the data frames. Okay? That's the simple averaging method originally implemented. Now, in the rank thing, and I don't fully understand this code, which is why I need to dive into it with a simpler example and work through it. But the reason I say that to me, and that's what I'm missing something, is let's say I rank order my first data frames values, right? Which means all I've done is through the org sort, I'm rank ordering them, which means that instead of having S0, S1, S2, S3 to S23, all I'm doing is saying, oh, the column which gave me the best result is going to be put first, and the column, it's going to be sorted in the order of the scores, right? That's the rank. The score which is highest goes first, and all the other scores go after it in the sequence of their rank. But the row still remains the same, and I still multiply by the same value. So the fact that I've sorted the rank,
no.
How does it change?
So,
what am I
the
missing?
thing is completely different. Like, let's walk through this code like line by line. First, you get the scores. Like your DF contains the current scores, right?
Correct.
Okay. Now we create an empty array or matrix of the same shape as DF. So this is kind of empty matrix, and now
Correct.
we get like sorted values of the like we get
column.
Indices sorted by scores, and now we set these scores for each of the
rows, right?
Yeah, for each of the columns. Yeah, so we set those scores for you see, this O is an index basically, right now, and
no, it's because it's the set of indices for the entire length of DF times 24, but arg sorted along the columns. That means that for each row, you will have a set of indices where it goes from highest score to lowest score. Am I right?
So
that's what O would be, correct?
So my understanding that O is is an index, so it contains basically indices. It doesn't have scores, right? Do we agree on that? All right.
Yes.
So now we take this first index would be NP arrange length of data frame, which would get us just a row of from 0 to the size of data frame 1992.
Right. 1992 times 24.
Yeah, and O is our indices here, and now we get this NP arrange 24, which gives us just a kind of array from 0 to 23, right?
Correct.
Filled with numbers 0 to 23. And this none just expands the first axis here.
Yes.
So to make the broadcasting work. And now our scores are numbers from 0 to 23. They are independent of the original scores. So those are just numbers. 0, like according to like what we kind of just the rank of the corresponding index or corresponding element. You know, kind of what I'm saying. All right, so that makes our scores completely different from the original scores. They are in the same ordering, but those are different numbers and scaled as we like as we decided here by just going from 0 to 23. And now if you do the weighted sum of those scores, you might get a different ordering, because in the first case, say the difference in scores were really kind of small, and the impact like basically the change in ordering dependent on the difference between actual scores. And now the change in ordering depend in difference in the ranks, right? So if we had like a small change in score, but which resulted in bigger change in the rank, say we have like really dense area in the ranking, so that ranks from say 5 to 20 like have really a small difference in the score, and then they're kind of weighted sum of those wouldn't change really a lot. But if you now that we moved from scores to be ranks, the difference is quite significant, because it's no matter what the actual scores were, now the difference is from 15, because it's 5 to 20, right?
I see. I think I'm beginning to get a glimpse of what you're saying.
Yeah, so that's what I refer to by saying that's kind of nonlinear mapping we have here.
Okay. I see what you're saying. So it's because it is by nonlinear. Actually, what you meant is that it's not the difference in scores; it's the difference in ranks.
Yeah,
and the difference in scores don't correspond to the difference in rank.
Yeah, so scores could be like, okay, can I draw like Alex did? How can I draw?
Yeah, I can stop sharing. You can do whatever.
Yeah, but I think it wouldn't
Yeah,
help.
you can share.
I don't have any kind of drawing tools here.
You can still share and you can draw. So can you keep sharing? You can click the pen at the bottom left.
Okay, bottom left. Let me just find it. Might happen.
It's a screen. It's a screen that is sharing. You see at the screen that is sharing at the bottom left, you have a pen. Can you see that?
I don't have a pen. Maybe my interface is different.
Where it says annotate, you mean?
You see annotate? I think it's not. It's just a pen. If you click on that, you can see something you can draw.
Okay, I don't see a pen. Annotate. I clicked and annotate, and now I have. Okay, and now I draw with annotate. All right, so maybe the interface is a bit different. So let's just imagine this scores to be kind of a function, right? So let's imagine that we sorted the scores like by rank, and the original function might look something like this. You know, it's like not a continuous function, but discrete. We have just points here. It's just easier to draw. You know?
Yeah, got it. Yeah.
Okay, and now that we map it by this arcsort and NP arrange thing, it becomes like this, right? So from that, it transforms to just a linear function.
Because it is rank ordered.
Yeah, so that would be our score, and that would be our rank, say. And here again, it's rank, and this is a score, and now it's just a line, like, or they are like arranged along a line, but before those could be like completely different depending on what our network learned. And yeah, so this does not explain why would this work better, but this definitely should explain why this works differently compared to the previous one.
Yeah, okay, got it. Or what is being done differently. Basically, in this case, you're using linear separation between 0 and 23 as kind of your metric to separate because only the rank matters. Whereas in the prior case, you're using whatever the model's output values that are generated, and the values, as you alluded to when you said that, you know, there could be dense regions and there could be sparse regions, and this rank averaging kind of gets rid of that, if you will, because everything is supposed to be spaced equidistant in a way.
Yeah. So if you take these 2 points here, and imagine that I draw it.
Right. Yeah.
The difference here is really small, and the difference here is larger. And now when you combine 2 models, maybe like depending on what those models outputted, maybe this model really didn't kind of make a lot of difference in these 2 scores, and another model made kind of more, like really assigned, say we have like scores from another model which are kind of like this, and something like that. So you see that and after this ranking trick, so those would be like very similar. And now you can like add this weights, and basically by adding weight you can like really add more like contribution to the first network and less contribution to the second network, but still this kind of changes quite significantly, right? How your order would be after ensembling. So,
and I think the additional benefit of this ranking ensemble is that it's kind of agnostic to the model outputs, because let's say you have one model that will output probability, another model that is output a number, something like rank from 0 to 100. If you use this ranking ensemble, you kind of align them into the same scale. Because you can express the model output as a relative rank. So it's easier to compare or easier to ensemble.
Yeah, no, you're right too, because the only thing you care about is the rank. So as long as you kind of collapse both of them to a rank, you don't care about, like, you're highlighting how you got to the rank.
Yeah. And logits are like, we use logits here as a scores, right? And those are kind of arbitrary in some region. So like if you like recall this sigmoid function, right? It's kind of it's insensitive in like after saturation, and basically like a really high value or somewhat lower value, but it still saturates sigmoid. We don't care when computing the like binary cross entropy, I guess, or not like don't care, but the contribution is different for kind of like if we misclassify or if we classify correctly, we then don't care as much. Like, are we like 99.9% sure or just 99.5% sure, right?
Cool. Yeah. Okay. So, and I'll post the link, which is actually dated. It's 2015, but I thought it was a very good post because it took you through all of the different types of ensemblings that could be done. And I got to that because I kind of
I still have
Kaggle
this original question, which was more like what was the relative improvement you observed by moving from a single model to ensemble of 5 models, like trained with cross-validation? Do you have those numbers?
Let's see. Yeah, now interestingly, what I saw, and I can only share one point way back from what I did, which point to it may be insufficient answer or an incomplete answer in the best case. So somewhere along the lines, as I was beginning, I think this one. This is interesting, but I don't know that it's a complete answer to your question, Otto, is because later on I noticed that there is a slight difference. If you look at these two results where it says baseline with stratified k-fold and then all-in-one baseline for beginners. My recollection, and I could be wrong, is these two are largely similar. Okay, they're not identical, which is my caution why it might be an incomplete answer. But I do recall that this particular guy used only one fold. And this guy began, or this notebook, I started to use stratified 5-fold. Now, if you saw here, strange, or, I don't know that is necessarily strange. I just think that I got lucky with what happened here. And this, therefore, I treated as my realistic baseline than that guy, because this guy was just with one fold, and my thought process at that time was, well, I just got lucky with the fold I selected. I could have been much worse, and this thing gives me a more, I guess, for lack of a better word, consistent result, because I'm using 5 folds to do it. But there are several caveats. I don't recall whether these two are exactly the same. It'd be trivial for me to go back and, try. If they are different, then to just go back and rerun this with just one fold and see what it gives me versus the 5 folds, what it gives me. But this is as close to answering your question from my many runs that I have.
Oh, okay. I probably will have the results for like my network tomorrow, like how it performs with like a single network compared to 5-fold. So no need to rerun it, anything, I guess.
Yeah, but I was just, I do recall this, looking at it and being, somewhat surprised, but then I just rationalized, well, I mean, if you're selecting one fold, you can get lucky as well sometimes. But this one is better. But again, one of the disadvantages of the chunking approach is the fact that when I chunk, because I'm just predicting a single value within the chunk, within the 5-second window, for example, and in fact, that's another reason to narrow the window, because we know that there are many, as Alex pointed out, there are many missing samples. And the longer the chunk that you have, then it's possible that you don't have just a single example in that 10-second chunk. I think Steve alluded to that as well. Although, as we have seen, most of the samples, I think I saw somewhere else that doesn't seem to be a big problem in this data set, but it is potentially could be a problem. But so when you chunk, then one of the things you can't do is, because you just have one prediction within that chunk, there's also nothing like, you just have to rely on accuracy or F1 score or some other metric. There's no label weighted or label ranking that you can do in a chunk because you just have one prediction.
I think it's not the case.
So that's
not the case.
Sorry?
I think it's not the case because in the all-in-one, so you see the all-in-one notebook, it is using a chunk approach, right? If you look at this notebook, it is using a binary cross entropy as a loss function. So it treats every class independently. So it is possible you can output multiple class in one subclip.
Yes, this one probably, but since I built everything based on this guy, it just uses cross entropy, not the binary cross entropy.
I see. Because I'm using the all-in-one approach, it's not exactly the same. I use the same loss function, which is binary cross entropy. So in this case, it's fine.
Mm-hmm. Yeah, if you do that, but in this case, I'm just using cross entropy since it's just single prediction within the chunk, then you can't do that. Or at least I can't do that with this approach. If I do, like you say, binary of each one, then you can do that.
Yeah, there is kind of, I think, like caveat to it, because during training, your network never saw a zero predictions, right? So it always sees a frame with some class. And during validation, you kind of expect the network to output a bunch of here is nothing predictions, because there is not always a label there, and I think that is one like if you eliminate that, that might kind of solve a part of that problem with false positives.
Yeah, agree. Okay. Thanks, Alex, for sharing, and Arto for your comments. I think we are at noon. So we'll meet next week, and I'll run some of the experiments and see whether I can push and get past the 0.9. And hopefully Steve will could have caught up or even exceeded us by then. And we'll meet again next week. Thanks, everybody.
Yeah,
Thanks for joining and sharing your work.
Cheers.
Thank you. Bye.
Thank you.
See you next week, guys.
See you all next week.
See you then. Bye-bye.